everybody. Today I am going to be talking y'all through the more recent history of astronomy. My partner for this topic was Ellen Wolfe, and she covered the BC, like more ancient side of the history of astronomy. So starting in the 16th century, so kind of our medieval astrology and astronomy, I'm going to start with Copernicus. So Copernicus was the first person to um, propose the heliocentric model, and that is that the sun is the center of our galaxy, and Earth and the other 5 planets that were known about at the time orbit the sun. So you can kind of see the background image here. We've got this is the old model, the geocentric model, with Earth in the middle, and then the other heavenly bodies orbiting around Earth. But Copernicus, he was the first one to say that maybe we actually orbit around the sun. He assumed that, like other astronomers at the time, that celestial bodies orbited in uniform circles. He predicted that even though he couldn't see this at the time, they didn't have the technology to study Venus as close as you needed to. But he said that Venus should have phases like the moon if it orbited the sun. So if we were to be able to see Venus close enough, we should see phases. So like full Venus or half or a crescent, kind of like the moon. So that was one of his theories. The heliocentric model wasn't actually accepted for about 100 years. People did not want to let go of the idea that the Earth was the center of the universe. At the time, observations and experiments, so still the medieval time, they weren't clearly defined and they weren't really used to compare theories. So even though there were these two contrasting theories, people were not driven or had the knowledge to actually compare those via observations and experiments. And one of the big arguments to the heliocentric model was that if Earth was flying around the sun, as Copernicus proposed, that people would feel that motion. Things would fly off the surface of the Earth. The Earth wouldn't be able to hold itself together. People were like, that doesn't make sense. We would feel it if we were moving that fast. So here's a picture of how Venus would look if at the time they were able to have a telescope to see this. If it was the geocentric model over here on the left, where Earth is the center of the galaxy and planets are orbiting around us, you would always have the sun between Venus and Earth. So you would always see it as sort of a crescent that was being illuminated. Versus if we were orbiting the sun, sometimes we would see Venus almost as a whole sphere in the sky, versus other times where we would see it as a kind of half of Venus or a crescent. So let's move on to the 17th century. So in the 17th century, 3 notable names. There were more astronomers, but these are just 3 big ones, were Galileo, Kepler, and Newton. So starting with Galileo, his big study was in the field of mechanics, so motion. He didn't invent the first telescope, but he was able to build one eventually that had 30 times magnification. So he was the first one to build a telescope that strong. And he was able to use that telescope to discover 4 moons orbiting Jupiter. So this was really a big deal because it gave us evidence against the geocentric model, because we were able to see other things besides just our moon orbiting our planet, that moons and smaller bodies can orbit other objects in the galaxy. So that kind of gave a little bit more fuel to the fire to build on the heliocentric model, because one thing that people had said against, Earth can't be orbiting because the moon wouldn't be able to keep up. So that was one geocentric piece of evidence that they thought, was that the moon was orbiting us, so we had to be at the center. Otherwise, the moon would just not be able to keep up with us. With that much stronger telescope than had been invented before, Galileo was able to confirm Copernicus's theory about Venus's orbit. So he was able to map Venus and see those phases of Venus, which gave even more evidence for the heliocentric model. And just a fun fact, the church was really not very stoked on Galileo, providing more evidence for the heliocentric model, and his books were banned by the Roman Catholic Church until 1836. And actually, it was not until the 90s that the church finally said that they did something. They kind of erred in their choice to ban these books. So I think it was 1992, which is pretty funny. Right, and then Kepler. So he came up with, they're pretty famous, his laws of planetary motion. So 3 laws, just kind of basics of those. He was able to show that planets do not orbit in uniform circular motion. They actually orbit in ellipses, where the sun is at one foci of the ellipse. And then the second and third are a little bit more mathy. The second law states that if you join a line from the planet to the sun that it's orbiting, even though it's moving in an ellipse, for some amount of time, it'll sweep out an area. And for that same amount of time, no matter where it is in its orbit, it will sweep out equal areas for equal times. And the last one compares the orbital period, so the time for one orbit, and the semi-major radius, essentially. So the ratio of the square of the period to the cube of the semi-major axis is the same for all objects orbiting the same body. So this was useful for comparing orbital periods, so the time for an orbit, and distances for different things in the same solar system. Kepler also created the first refracting telescope, and he was a student of Tycho Brahe. I think I'm saying that right, I'm not sure. He was a 16th century, so back in more of Copernicus's time. He was known for taking really accurate measurements of stars in the sky, which is pretty cool. And let's move on a little bit. Oh, sorry, don't forget about Newton. Someone else this week is covering Newton's laws and kind of focusing on Newton, so I don't want to go into too much detail. Just basics. His major contribution is his 3 laws of motion. So first law, objects remain at rest. So either in a straight line at a constant velocity or at 0 velocity, unless there's a force acted upon them. Second law, force equals mass times acceleration. And third law is that equal and opposite reaction forces. These were super important in furthering the study of astronomy. Right, and then going from the 18th and then kind of starting the 19th century, let's look at 3 big names. We've got Foucault, Messier, and Laplace. So Foucault's big contribution was he built a pendulum that proved Earth's rotation around an axis. There's actually a few of these in some museums that you can go and see. But the idea was that, as you can see by this little GIF here, a large pendulum, if it swings in a body that's rotating, it will not just go back and forth along a linear path. It will make this sort of star pattern. And so you can actually see this with a long enough pendulum swinging back and forth. It will eventually change angle. Right, and then Messier, he was able to identify 110 nebulae and star clusters, and all those objects were named collectively the Messier objects. And down here is a picture of the Orion nebulus, I suppose, that he drew. And then Laplace, his big contribution was more on the side of math. So he transformed some previous geometric mechanics to calculus-based mechanics. And he was actually the first one to suggest the evidence of black holes, which was pretty crazy for the time because this was still the 18th, early 19th centuries. Right. So what I'm going to end with is kind of moving into the late 19th and 20th centuries. I'm actually just going to propose your homework problem now. So your homework problem is to choose two notable astronomers from the late 19th to 20th centuries and describe their contributions to the study of astronomy. Down here, I've got quite a few people. I've got 8, but there's dozens more that you could choose from. So obviously, you've got Albert Einstein and Stephen Hawking and Carl Sagan, but there's also some other names. You've probably heard of Hubble, but I hadn't heard of Annie Cannon, Harlow Shapley, Arthur Eddington, or a couple of these other guys before. So maybe choose someone you haven't heard of. That could be kind of fun to look into. But lots and lots of people to look at and see how they contributed to astronomy. Thank y'all. See you next week.